not just manage it. We have the scientists in our organization. We do science in all 5 divisions of science in NASA. We're one of 3 centers that does that. So we do astrophysics, heliophysics, earth science, planetary science, and biological and physical sciences. In addition, we do all the technology management. I'd love to say I have a lab and I do technology when I go into the office, but what we do is we actually manage engineers in our center that do the technology work. I wasn't going to say this, but I'd like you to look at the people on this chart. I think they are a good representation of our society, and they are a very strong team. Something that really came to light for me when we hit the pandemic. I think it was March 13th. We were all at an offsite together in a small little room when the first positive COVID case hit Marshall. And we went home that evening, and we haven't been back as a full group since. But we've really grown, even though it's remotely, as a team. So, okay. Let's see. It's not advancing. Thank you, Kat. There. Oh, there's too many. Okay. There we go. All right. So here's where I expect the boo. I graduated from the University of Tennessee in Knoxville. I had no idea until my children started here that there was such a rivalry. I thought it was between Alabama and Auburn. But I have to say, when I graduated, I felt like I had a pretty good education. I was very excited to get a job. I came out of school pretty naive, pretty introverted and shy, still am. And I chose Marshall of all the places I interviewed and got job offers because one of the people I interviewed with actually had looked at my background and said they needed somebody with my exact expertise. I was pretty darn good in mechanical engineering, even though I was an electrical engineer. And for me, one of the drivers of going to work is that I want to feel needed and making a contribution. So I didn't even really know a NASA existed in Huntsville. I thought it was the Space and Rocket Center. And believe it or not, most people do when you tell them that there's a NASA in Huntsville. They think it's the Space and Rocket Center. But I got myself in a car, came down, and started a job in the control mechanisms. That's a hydraulic facility for an electrical engineer. But what I did was I worked on electromechanical actuators. They've been in use a long time. Usually they're kind of small. These were the solid rocket booster actuators that flew on a space shuttle main engine. So some of the largest actuators in flight. And what we were trying to do was convert them from hydraulic, which actually, if you look at all the space shuttle data, had some of the most major issues and also safety issues. So we thought we were going to change the world and turn them over to electromechanical actuators. Great experience, fantastic experience. I was in the lab. I was actually, doing things. I'd like you guys do in here with the Astrobotics lab. I inherited a facility that they actually used in movies because it still looked like it was in the 1950s. And I took that and I converted it. We got digital data acquisition. It was a huge transformation. I put in electrical, everything. And then before I reached 30, I'm going to tell you, I put a lot of work into it. I was promoted. Okay, I was team lead over this group. And so more than what I did, the thing I learned from this experience is that when you leave college and you go to work and you have a work family, you're with those people 8, 10 hours a day, you develop really close relationships. And when you change from team member to manager, you need to be prepared for those relationships to change, right? Some of you may have had jobs. I know a boy that worked at McDonald's and he had the same thing, right? He loved going to work, hanging out with the guys until he was responsible for what those guys did, right? So some of the fun that they had wasn't as fun for him anymore when that relationship changed. But it was eye-opening, and it actually set the tone for how I manage, because I had to step back and not only think about how I felt about the change, but how they felt. And when you can actually work with a team thinking about how they're perceiving things, it actually changes the way you treat people, right? And that's really been successful for me through my career. So I learned that the hard way because it wasn't a smooth transition, but I did get there. I'd say I was there for 7 or 8 years, not in total. And I was starting to get a little frustrated, and I don't know if you guys have this experience where you have great ideas, right? And you go and you want to get them funded, right? And you go to the people that hold the money and you tell them the great idea and they agree. It's a great idea, right? And you tell them how much it's going to cost. And they say, well, I've got, let's just say, I said it was $1 million. And they say, well, I've got 25,000. What can you do for it? I'm not making that one up. And so you figure out what you can do for that 25K, right? And you inch it along. And next year you go back and they still love your idea. They like that you made some progress. What do you need? And you need $1 million. And they're like, we don't have it. We got 25K. Third year you go back and they're like, aren't you done yet? Right? So I wanted to educate myself and learn what the project office was thinking so that I could go back to engineering and help what I wanted to do, right? Help advance it. So I took a job in space propulsion office. By far the coolest, my most favorite job I've ever had. It was awesome. We did cutting edge technology for the Science Mission Directorate. It was propulsion technology that was going to enable greater science. So everything we did had to be tied back to enabling science. So I put some examples up there. The top example is a solar sail. We deployed that in Glenn's Plumbrook vacuum chamber. At the time, we thought it was great. It was like 20 feet on a side. It was very thin material, and I'm going to show you in a little bit. The material is about the thickness of one of your hairs, one hair, not a ponytail, but a hair. And it works by reflection of sunlight, and you can actually get propulsion from it. In the middle is a technology called Aero Capture, and it's where you use a blunt body to go into an atmosphere of a planet or Earth to actually slow down and capture into orbit. So you don't have to do braking, you don't have to, and it's a great concept. We're still not there yet, but we are working, NASA is working on a project called Lofted. And it's an inflatable decelerator that will launch, oh gosh, maybe 2 more years from now and actually capture in Earth's atmosphere. So that technology is still moving along. And at the bottom, the glow is an electric thruster. These have been used before. Actually, I went from this project and I did some consultation on some missions. We've flown it on the Dawn mission. And we are getting ready to fly it. I think it launches, I want to say the 4th of December on the DART mission. You're shaking your head. I may be close, right? When you actually, this is an ion thruster, and you use electromagnetic ions that, when the thrust is, if you take a grain of rice and you drop it in your hand, that's about as much thrust, but it's constant. So you start slow and then you accelerate, and it's a pretty efficient propulsion system. So what did I learn there? As I was going into this job, I was getting married, having children, and it seemed like full life, lots of energy. And this is about as personal as I'm going to get. I love this job so much that the balance between my personal and my professional life started to suffer. I had small children. My husband is awesome. He enables me to do what I do. He is a great father. And he was picking it all up, right? My kids came to visit me on Mother's Day at work. So something was off. So I realized it, talked to my husband, and we decided a change was necessary. And I left this job. I left a job where we started with like 5 people. We grew the office to 40. No one left. I was the first person to leave. It was really a family. But my family had to come first, okay? You guys may choose to go a different route. You may not have families when you go to work, but there will be something in your life that you need to pay attention to. And work does not need to cancel that, right? So I did leave. There's a job or 2 in between there, but the next one I was going to talk to you about is going back to engineering from the project office, because I do like engineering. I was the deputy manager of the flight mechanics division. And while I was there, what we primarily focused on was the Ares 1 and the Ares 5 launch vehicles under the program called Constellation. We did all of the guidance, navigation, and control in-house. We didn't contract it out, we were doing it. We did the failure detection and response systems. And we also did all of the natural environments, right? What it was going to see as far as impacts from meteoroids, things like that. Great experience, wonderful experience. Worked with fantastic people. I was the only non-PhD in the management team. And what they told me was they needed somebody to do the work. So that was me, because I didn't have the PhD. But if you guys know anything, this was a while ago, so I don't expect you guys to know it, but the Constellation program was canceled rather abruptly. Okay. And again, a lot of people investing a lot of time in trying to make that vehicle a reality. And what we were faced with was, if we didn't have work coming in, some of our team would have to go home, which was crushing, right? First of all, you lose something you've poured your heart and soul in, and then the idea that something can go away. And this is not just NASA, it happens in industry, it happens across the board. So what I learned from that experience was the importance of transparency and being honest with people, right? It would have been really easy to tell people not to worry, that everything was going to be okay. But my manager and I got together and we decided we were going to tell the truth, right? This is a really tenuous time. Please stick with us, that sort of thing. We were able to keep everyone at the end of it because there was another program starting up. But I can tell you that our organization went through a lot less turmoil because we were honest and open. So I think that's a really important part of working with people. From there, I actually did a few other jobs, but then the next one I'm going to talk about was I became the manager, not the deputy, for the Structural Design and Analysis Division. Now, some of you guys are probably thinking that's a little strange, right? I'm an electrical engineer. I'm going to be honest with you. Most people in that division thought it was a little strange too. Okay. It was probably the weirdest interview I've ever had. I went in, I can tell you, I went in flip-flops because it was my interview was supposed to be the day after, and they called me up early, and I'd just come back from vacation. And I walked in, and it was the branch chiefs. It's the people that would be directly under me and the person that would be above me in this job. And the people that would be below me said nothing. They just watched. But they were actually the ones that made the decision, right? So I knew I at least had some allies when I walked into this highly technical mechanical field. I'm talking loads and dynamics, mechanical design and structures, aerodynamics, aerothermal, and thermal, okay? And for launch vehicles, so the whole kit and caboodle. And what I learned is if your team believes you offer some value, you don't have to be the technical expert, okay? They chose me, so it's their fault, right? So they were invested. And they gave me the top cover to show that I actually had something to contribute to this group. That team ended up being one of the strongest teams I've ever worked with. I am going to be one of the proudest mamas when SLS flies because I know this team had so much to do with that, and we did it together. I offered them something they didn't have, and it wasn't electrical engineering by that time. It was more in management. But if you actually trust and empower those that have the know, you're going to get things done. So that's what I learned from that job. Then I'm going to jump to 2015, 2016. I got a phone call from somebody that I trusted, and they asked me to consider applying for something called a career development program. It was something that NASA and other government agencies do to develop senior leaders into executive leaders. And that's not something I ever saw myself. Because when I said I'm an introvert, I really am. I'm very shy. You know, the joke, the difference between an extroverted and introverted engineer, you guys know that one, is an extrovert looks at your shoes and, and an introvert looks at their own when they talk. And that's kind of me. You never heard that one? No. So I actually went ahead and I applied. It was the first year that NASA had this program in about 7 or 8 years, so there were a lot of people interested. And it was the first time they did something differently. Usually what they do is the centers look at their leaders and say, these are the folks we think are ready, and they go up and they compete. This time they did it grassroots. Anybody that wanted to, that met the criteria, could compete. And believe it or not, I was selected. Out of, I want to say it was almost 600 people that applied, they picked 24, only 19 of which came from NASA. They picked 5 from other government agencies. I went into this program a little apprehensive because they let us know that it required a 6-month detail away from your home center. Okay, this time I had kids in junior high and high school. As a family, we decided I'd go forward, and I did it. And what I learned from this experience, I actually got to do a detail at NASA headquarters. Not just at NASA headquarters, but in the administrator's office up on the top floor of the NASA building, right? And I remember, man, I was homesick, right? I'm in Washington, D.C., don't know a soul. I'm going to give you a hint. If you go get a job in Washington, D.C., don't expect to meet a lot of people that hang out after work because everybody lives somewhere else. They all go out. But I remember after getting over the homesickness and all that kind of stuff, walking down the hall, and it's got all the NASA administrators from the history down there, and being excited to learn something new. And that's something that I'm trying to carry forward. I learned through my other jobs, but I didn't make it a priority to learn. Definitely changed my perspective. I actually seek out stuff that I don't know now. Also pushed me, this quiet introvert, had to go to classes. I actually did a class where I chose to get up and do Shakespeare. So really pushed out of the comfort zone. And I encourage you guys to take every opportunity you can to do something that you don't feel comfortable with, right? That you think will grow. It definitely changed the trajectory of my career. So after that time, I came back. I did graduate. And I was selected, believe it or not, to give the speech at the graduation that thanked all the family and friends and stuff like that. I thought that was a huge leap from being the quiet person to actually doing that. But I came back and I actually went back to this job. I loved it, loved the people. And I got a call about 2 months in, inviting me up to see the engineering director, who proceeded to tell me that I was no longer working there. The center needed me to do something else. Now, remember, I just told you, I said, I like to do things now that are out of my comfort zone. But what he asked me to do was start a new office at the center that was responsible for bringing in new work. I couldn't sell water in a desert. This was so far out of what I thought I could do. But I went back to the things I learned up there about how you treat people. I worked with the leaders at the center. Within 6 months, I had the office set up. We're doing anywhere between $30 and $50 million for Space Act agreements a year, and it was going well. From there, and what he was doing, he wasn't really firing me. I felt like it at the time. I got fired out of engineering. Is he was putting me in a position so that my senior management could see that I could lead, even though it was not in my comfort zone. So I have a lot to thank him for. Actually, the job that I have now came from this job. So I'm going to talk to you about that. This is the part you might be interested in. Okay, so I actually got an executive position from that job. I was selected to be the deputy for the Science and Technology Office. And I can tell you, I've also been the director. A month into the pandemic, my boss announced that he was going to headquarters on a detail. And so I spent 8 months during the pandemic leading the office. Again, out of my comfort zone, I went from just being the new executive to being a direct report to the center director. Actually, it was a very good experience, and I developed a lot of the relationships I have now with the rest of the management team. So get things that you might be more interested in than my career, but I hope that helped a little bit. You're gonna, most of the learning you do on your jobs besides technical are gonna come because of experiences like the one I told you. So what do we do in the Science and Technology Office? Well, we do a lot of things. I feel like we have all the cats and dogs for the center. But we actually have some center level responsibilities. We host the chief technologist for the center. There's John Dankinich. We have the chief scientist for the center. And these people help develop the strategy of where we need to go and what we need to do. And so they both work for us. John actually has 2 jobs. He actually works for headquarters as well as a systems capability lead for in-space propulsion. And then we have a cryogenic fluid management office. Remember I told you about the the human landing system, this is an area we're trying to grow into something bigger. So that's what he does. We have a PP&C, they handle our budget. And the partnerships and formulation office. Reggie has the job I used to have. He's much better at it. He's really good. And his responsibility is actually, where are we going? What do we need to invest in? And bringing in industry to come work with us. So he does a good job there. In addition, chief engineer, safety and mission assurance, and Tyler's our procurement specialist. You can't do anything without procurement. So this is the meat and potatoes. Our science research and projects division. Again, I told you we had 5 different types of science that we do. Between the first 2 boxes, we're the second leading, I want to say, customer for engineering at our center. We bring in a lot of different technologies and science. I'm going to cover some of those in a minute. I'm just going to go through this quickly. Then we have our exploration technologies and system development division. We have small missions that we fly. We are getting ready. It's already packed and ready to go on the Space Launch System. I told you about the solar sails. We have something called the NEA Scout solar sail. It's going to fly on a payload, secondary payload. I don't think it's called Nest Ring. We have one we developed ourselves, and it will launch on the first Artemis 1. And it's not a huge solar sail, but it's one that we developed and will probably demonstrate before the next one I'm going to tell you about, something called adaptive mass translator. It actually will steer that huge solar sail by moving mass around the center of gravity. Right? In addition, well, I'll tell you about that later, but those are the kind of things we do. We develop thrusters, additive manufacturing, in-space manufacturing. Try not to tell you any of the ones I'm going to talk about. Plume surface interaction. Actually, when we're modeling what a thruster does when you come down and land a lander with the ejecta and things like that. So we're doing that kind of thing. So we have going on. We have thrusters that are going on the first CLIPS missions, things like that. And we also have some instruments that are flying on the first CLIPS mission. So it's pretty cool. So they actually manage work that is done at Marshall, the project offices. The next 2 boxes are terribly important to the agency. They're program offices. And I don't want to, if you guys know the difference between a project and a program, excuse me, but the program office has managed multiple projects, right? A project has a beginning and an end. The program office doesn't. It has different projects that it does to get to a goal. The Planetary Mission Program Office manages over $1 billion a year in science missions. They just launched Lucy. They'll launch DART early December. If you've watched the news, we've just announced 2 missions to Venus. Those are all managed out of that office. The project management is usually either at a center or academia or someplace like that. So these are really large missions. They do so well at that. I'm really proud of this group. They were asked to manage something called LCIP-P. These are smaller instruments managed by academia or small businesses that will fly on CLIPS landers. These are landers that we put out a blanket announcement that industry is putting together to land on the moon. So they've got the really small stuff and the really large stuff, and they're knocking it out of the park. So I'm really proud of them. And then the last one, has anybody ever heard of the Valley of Death for technology? Maybe? Okay. That's usually, if you look at TRL's technology readiness levels, somewhere around 6. You've done most what you can do on the ground, and you need some relevant environment to demonstrate it. And I'm going to be honest with you guys, because I love technology. missions don't really want to be responsible for that. They want somebody else to show it works in the environment they need it, right? Because it's too high risk not to. So there's a program called Technology Demonstration Missions Program. It's run out of the Space Technologies Mission Directorate at headquarters. And it takes technologies from pretty mature on the ground technology to flight. The lofted mission I was talking to you about earlier, the inflatable decelerator, is a TDM mission. The PMPO office, the first one, none of those missions are at Marshall. They're totally independent. And that's why the Science Mission Directorate likes it where it is, because there's no bias towards your own center. Until recently, we had the same with TDM, but we actually have two missions that we have going with them. And I'll talk about one in a minute. The other's the CFM, right? Cryogenic fluid management is going to be necessary to take humans into deep space. You can't keep fuel from boiling off. And so that's the technology that'll do it. So that's what we do. There's other things. We do tech transfer. We have something called the Centennial Challenges Program. Has anybody ever heard of that? You've heard of that? That's in our organization. Look for announcement really soon on their food challenges. Martha Stewart's going to actually be on that announcement. So we're excited. They had Alton Brown at the kickoff, and now they're going to have Martha Stewart. Okay. So, sure, I'm almost out of time, so I'm going to go really fast. Solar Cruiser. That is a science mission. It's not a technology demonstration. We have graduated solar sails to a mission. Now the mission is to demonstrate the technology, but what you've got there is, again, material thin as hair, highly reflective, booms, 4 booms made out of composites, 100 feet long each. This is 18,000 square feet of surface area. It will be launched in 2024, hit a trajectory that's going to be just sun side of the L1 Lagrange point, and set up orbit around the Lagrange point for about 2 to 3 weeks. Then it will lift itself out of the ecliptic plane to show that it can actually monitor the sun's poles. Okay. The importance of this is that if you are a heliophysics scientist, having this kind of observation of the sun is holy grail, right? Because it's constant, there's no propellant, so it can stay there for a long time. So it can impact not only science, but space weather information to the Earth, things like that. So that's why we're after that. Over on the far right is the Mars Ascent vehicle. I'm not going to go into detail, but we are planning at NASA a Mars sample return. We have Mars 2020 on the surface now. We at Marshall are responsible for the Mars Ascent vehicle. That's a vehicle that will take those samples to orbit, rendezvous with a Earth return vehicle, and come back. Okay, so we're doing that. Space nuclear propulsion. Really cool stuff, right? There are 2 flavors of that. Nuclear electric, where you take the reactor and it just does electric power, and you do the electric thrusters, like I talked about earlier. Or what we're probably more advanced is nuclear thermal propulsion, where you take the reactor, nuclear reactor in space, and you flow hydrogen through it, right? It heats that hydrogen, and you have higher ISP than your chemical engines. What I like about the NTP is that let's say you're an astronaut, you're going to Mars. Halfway through, you become sick. It allows for abort. It can turn back on and get you home, right? So I really like that technology. Where are we now? We're not ready to put reactors in space yet, but we are working with DOE. We've got 3 companies working for small reactors for space propulsion. So we are making progress. And the one that I'm going to ask some of my coworkers at Space Days next week, if you guys show up and talk to them, to talk to you about is double impact. That's Moon to Mars. Let me make sure I get this right. because all I call it is double impact. Autonomous construction technology. Okay, so you guys are going to do some excavation, right? We're going to take that and we're going to build, and we've actually done some prototypes in Texas, landing pads, structures, things like that. And you think that's far away, but the Centennial Challenges program actually had a challenge. And there's a company called Icon that we're working with that is actually printing houses in Austin, Texas right now. All right, so we're working with them on that. We're also working on materials and sintering of materials. So that's the double impact, and we'll make sure you guys hear more about it next week. Okay, science. I didn't talk much about science. Guys, lots to be excited about here. What I chose to talk about first was our impact globally on people's lives. We do something called research to operations and operations to research, where we take data from satellites and we develop tools for forecasting, tools for understanding. I mean, anything from, an example is, we've got a grant right now where we're working to be able to tell where flash flooding is going to happen by looking at the hardness of the earth. It's not where it rains, it's where it goes to, and that's those kind of things. But what you see here, the yellow or the green dots, are hubs that we've set up under a program called Surveyor with the United States Agency for International Development, where we work with local leaders and global scientists to do science that impacts at each of these hubs. And these are all developing countries. So we've done things as broad as impact of locusts on the terrain to disasters relief. It's something that our administrator actually goes around the world and talks about. It's huge and it impacts people's lives. So I wanted to share that with you real fast. One I'm most excited about right now is IXP. It's the Imaging X-ray Polarimeter Explorer. It launches December 9th on Falcon 9. I'm going to be down there. I'm excited. So you guys have all seen glare coming off of water, things like that. You put on your sunglasses and what do you can see, right? So if you're into X-ray astronomy, you know, these are some of the most wild physics in the universe. We're talking pulsars, we're talking, I don't know, nebula, all kinds of things that emit energy about the temperature of probably the center of the sun, not the external. What we're hoping to do here is we've already got X-ray observatories out. We've got Hubble, Chandra. We're getting ready to put up Webb, December 17th. But this one actually does polarimetry. It can actually tell you what those frequencies, what directions they come from. And we're actually thinking this are going to help us understand some of the astrophysics, the physics parts. Quantum electromagnetics, things like that. So we've got a lot of excited scientists. And I'll just say there's a human element to this too. Our principal investigator, Martin Weiskopf. I saw a picture of him just yesterday from 50 years ago. He was a grad student and the first polarimetry mission was launched. It's been 50 years. They took 1 pixel. This can image whole areas. So 50 years of his career has gone to making this possible. So if you ever think about why scientists and engineers are different, that's a hint, right? He spent 50 years trying to get here. And December 9th, I get to see him realize it. So I'm terribly excited. Okay, and last one, then we can ask questions. I'm from Marshall Space Flight Center, so I cannot get off the stage. This is not mine anymore. But we are planning on launching the Space Launch System early next year. Yeah, it can take 85 metric tons. Think about 12 adult elephants, right, in space. It can evolve, plans to evolve to about 130 metric tons, and this will actually allow us to set up for exploration of our solar system. So I'm terribly excited. And that is all I was going to say, other than this is outdated. I want to tell you, we've already got all our CubeSats loaded. They're ready to go. Got 2 from my organization ready to go. Testing is almost completed. The simulations are in progress. The Orion is actually stacked on top. So if you would get to go down to KSC, you'd get to see the full stack right now. So I think that's it. So I went way over. I'm sorry. Questions? I'm fine. Yeah.
So I noticed that you were talking about different experiments on
Really strong management team, right? I have to trust them. But what I get is usually the problems, right? When things aren't going right. And that's the way it should be. I'm not complaining about it because then I have more access to get help for them. But this might bore you, but I do get weekly updates from the organizations, and I can go to sleep reading those some nights, right? Because I try to stay on top of it. But I've learned, and I'm just gonna be really honest, to say, I don't know, I'm gonna find out, because there's so much, right? It's not a comfortable place to be, but I've learned. But that's kind of what I do. Anything else?
You mentioned that you were the only person who had a PhD.
I will tell you, I spent probably the first 10 years of my career wanting that PhD. Right? Yeah, I wanted that PhD. And if I had stayed purely technical, I think that PhD probably would have helped me. But because of the career path I took, I think I'm okay without it. I loved being the only non-PhD because I could tease them as bad as they could tease me, right? But I have to say, I do respect that they all did have those. They were very dedicated. So I don't know if that helps, but okay. Did you have a question? Uh-huh.
When we see it, what is the next step after?
Okay, so the first one is going to be non-crewed. Okay, so I'm not calling it a test flight, but it's non-crewed. We're going to make sure everything works. Second, we're going to actually start working towards an upper stage, a different upper stage. Right now, we're using the, it's not off the shelf because we had to change it, but we're using it's called an ICPS, Internal Control Propulsion System. So we're going to do a more capable upper stage. The third time we fly, we will have crew. Okay. If we continue to do that and we need for exploration, there are plans for improvements in our solid rocket boosters, give more more thrust, more power. But it depends, right? Because we have industry also involved in what the architecture calls for. We're not just going to keep developing to develop, we'll develop to meet a goal. But the first 3, that's how we plan to go. Okay. Anything else? Yeah. So having a crew on board anything you're going to launch changes things dramatically. your risk tolerance goes down. You actually have more requirements, more due diligence, more checking, right? Which ends up costing more, right? But human life versus the cost is probably a good trade. Some of these science missions, some of the technology missions, we do hard stuff and we expect some failures, right? And when people aren't involved, failures are a lot easier to take. Now, when I showed you the Planetary Mission Programs Office, those are Class A, Class B missions, and they cost a lot of money. So you're going to spend more money making sure that you do all your verifications, everything's just right. But in this day and age where money's tight, you trade higher risk where you can take it, which means you're still going to, the intent is to do all the right things, that you're just not going to have the checks and balances and things like that. I don't want you to think that we're not good stewards of your taxpayer dollars, because that's not it at all. But it's actually trying to step forward with the money we have and make advances. Does that answer that? Okay. All right. Okay.
So, speak a little bit about your experience. Talk a little bit
Yeah, I can. So when I first started, if I would have showed you the head chart that I showed you of Marshall Space Flight Center, if I remember correctly, that was a long time ago, there would have been 2 women on that chart. One was the head of our mission ops, and the other was the head of our human resources department. And that was it. I do not remember a female manager in my organization, probably the first 10 years that I was there. I mean, team leads, things like I did, but I mean, higher level management. But I saw change and it was coming fast. It never bothered me. I went to a school and I was one of 5 women in my class, my electrical engineering class. And so I was quite comfortable. It didn't bother me. But we started to have things like people would come talk to us about being women in the workforce. And at first, I'm going to be honest, I was like, I don't want to be treated differently. I want to be treated just like everybody else. I don't want anything different. And it took me quite a while to realize what they were saying. I did have some negative experiences. I was a team lead. I moved into a new building and I sat in a cubicle in front of a man named Werner Dahm. He was a legend. I don't know if you remember Werner Dahm. He was one of the original Germans that came over after World War II. And I was sitting on a telecon, leading a telecon. And I remember somebody grabbed me from the back and spun me around and told me to do my damn job. And I was just sitting there looking at him. He goes, I've been sitting here for 20 minutes and nobody's even let Werner know I'm here. He assumed, since I was sitting outside of Werner Dahm's office, that I was his secretary. That was a little hard to take, but I understood, right? I'm a pretty understanding person. He was a lot older, came from a different generation, but it was embarrassing, right? Because everybody on that telecon heard it. So that's the kind of thing that you had to either decide you were going to fight or just kind of live with, right? So from that point, I started going to some of the things they offered about women. And I remember to this day, walking into one of these meetings, it was like a room like this, and there were 4 women up front, women leaders, and they were talking about their experiences. And I can't tell you any of them said, What I can tell you is that what I remember most is there was a man sitting behind me. His name was Roy Malone, and he was there because he wanted to be able to support the women in his organization. So that I mean, it still touches me. He just retired about a year ago. So I've seen it, right? I've got, now you looked at that chart, not 50%, but almost for women, right? Still, I'm sure, I mean, you look at the paper, there's women generally make 82% of what men make in the same profession. But at NASA, I don't feel it. I don't feel it at all. I still believe there are going to be people that think that where I needed to be, where when I was at work was probably at home, and I respect people for their opinions, right? But I respect my choices as well. So that's what's make this country great. We have choices, and so that's kind of how I feel. To be honest, it wasn't always a battle, but there were times. Yeah. So, okay. I know there are tests. Any other questions? Okay. Yes. That's a good question. I've actually been on some study teams for that, right? It depends on how much international participation we get. I do think if we don't make 2024 for landing the first time, it'll be 2025. NASA plans on coming and going, not staying until there's actually a case for us doing so. But the goal is, right, we're going to the moon so we can learn from it, so we can go to Mars. So I would hope you would see something in the 2020s, because I think our goal is to get to Mars sometime in the 2030s. Did I see another hand? Yes, sir.
What sort of
Right now, I do know that I'm going to say NASA in general is very late on its summer intern. You're laughing, you know. Yeah, we generally put the call out for those after everybody else already has internships, right? And we a lot of times get people who turn others down after they already had them, and that's not really good. So we are actually making an effort this year to get ours out earlier, right? It's an effort, I can't promise it, but they will be coming out. It's my hope that they are not virtual this year. They've been virtual the last 2 years. For entry level, either last week or this week, there should be something out in USA Jobs, okay? And what those are term hires. And what we're doing now for a lot of our new hires is hiring terms. They're 2 years extendable up to 6 with conversion ability. So we've got that going on. Trying to think what else. You reminded me. In addition to those opportunities, I wanted to talk to you guys about something called, it's long, Lucy Student Pipeline Accelerator and Competency Enabler. They call it LSPACE. And it's an Arizona State University initiative that they work with NASA. Lucy, in this is the Lucy mission under the Planetary Mission Program Office. And our chief technologist started a program called under that, and this is free. The NASA Proposal Writing Evaluation Experience. And Pee-wee, has anybody ever heard of it? You've heard of it? Did it help any? Yeah. So we've had 1,000 people go through that experience. And why I wanted to talk to you guys about it is if you guys are considering grad school, right? proposals are pretty important when you want to solicit grants and things like that. So I wanted to make sure you knew that was out there. It's free. But those are the two opportunities I know right now, the interns, co-ops as well. Usually co-ops, we just move right into, at least right now, into permanent or term jobs when the co-ops are complete. And I believe at Space Days, we're actually going to have some, maybe virtual, but we're going to actually have a session on just that. All right. Guys, good? All right. If I didn't cover something you wanted, let Kat know, and I'll try to make that up to you guys. Okay. And that is the longest I have ever spent talking about myself. So don't ask me any more questions about myself. Thank you.